We haven't started yet, but in the meantime, if you want to do the workshop yourself and you want to already get a little bit started with pulling down the dependencies and stuff like that, you can already go to the first URL then, and or just type the whole URL with requirements / getting the workshop material, and then maybe we can load balance the network a little bit with downloading dependencies. I will also show everything kind of hands-on. So it's up to you. If you want to do the workshop yourself and you want to not listen to me, that's totally fine. You can just get started, and we have several people here that can help you. And then in a few minutes, I'll also just start kind of showing the whole workshop, because we only have 1 hour and a half, and we actually have quite a bit of content. So it might be a challenge to do the whole workshop in an hour and a half, but you can always continue at home too, because it's always online. And then you can always reach us too. But anyway, there's the getting started. Yeah, sorry. Yeah, so I'll share the key in a moment, but you can already get started with downloading the dependencies and everything, and then yeah, I'll share the link. Actually, I'll just add it to this slide as well. All right, so you can find the key if you click on that URL. Please only use it for lab purposes. Yeah, so we only have a few dollars on that key, so I think it should be enough for today. But if anybody runs into an error saying that at some point that our quota has been reached, I can fund it with a little bit more. But I mean, it should be fine, I think, because it really doesn't use that much.
Yes, and if you also want to try the same the same example, the same workshop with your own favorite LLM, or with something that runs locally on your machine, or you have another account, it should be fairly simple to reconfigure the workshop and use it. You just need, for instance, to add the dependency on Llama if you have a locally running LLM, or adding the dependency for your own favorite provider, and reconfigure the application properties file in order to use it. So it should be, and you don't need no changes in the code, so it should be really simple. And if we can help with this, let us know.
All right, so we're going to start with an introduction on the subject. So I hope those who want to just get started got the URL. If not, take a quick picture, and then we'll get started. I'll share this again in a little bit. Don't worry, it's not the last time you see this, but I will go to our regular slides for a little bit. All right. Okay, so today we're going to talk about agentic AI patterns with LangChain4j and Quarkus. Maybe a couple questions before we start. Maybe the first question is, who was in our lab last year here, where we did a lab on LangChain4j with Quarkus getting started? So just a couple people. So for you, this is the progression. So last year what we built was a single AI service. And this year we're going to build a fully blown agentic system. So maybe a couple more questions so we have a better idea of who we're talking to here. So first question, who here has worked with Quarkus already? Okay. And who here has already worked with LangChain4j? Just a couple people. And then who here has worked with Spring AI? Also just a couple of people. Okay. Any more questions that you can think of, Dimitris? We'll keep asking questions. Yeah, and we have here, we have a multilingual team here. So we have two Greek speakers, we have Italian speakers, Dutch speaker, all English, French, yeah, so any other languages, then sorry, you're out of luck. Or maybe some German. Yeah. Okay, so we'll introduce ourselves. So I'm Kevin Dubois. I'm a developer advocate at IBM, based in Switzerland, originally from Belgium. We have, I don't know if you want to introduce yourself or do you want me to just do it? All right, so we have Dimitris here, who is Greek but lives also in Switzerland. We have Georgios, or Georgios, I don't know, I'm terrible at pronouncing. Anyway, George, who's based here in Athens. So George is one of the core developers on Quarkus, and then Dimitris is the big boss, I call him. And then we also have Mario here, who's from Italy, and he's particularly working on the agentic LangChain4j stuff. And yeah, so that's us. And so we're all part of the Quarkus team. So if you haven't done anything with kind of trying to integrate AI into your application, you typically start with just a single AI service by integrating an LLM into your application, right? So what you will want to do is do some sort of prompt to the LLM, and then you can get a result back. And you can get that result back into your application. So you can get that back as a string or even an image or a video. And then you can do something with that into your application. And that string can also be then unmarshaled into objects that you can use in your application. So it's great that you can do that. You definitely want to become a little bit proficient at how to prompt models. As you probably already know, if you've ever worked with an LLM, the better you write the prompt, the better the result is going to be, and the better your result is going to be in your system as well. So this is great if you just want to interact with one LLM. But of course, you need a little bit more, right? So I talked about crafting prompts to guide the LLM to get an actual, useful result back, and you want to try to be as specific as possible. Then there's another key component. So if you directly interact with an LLM without any kind of chat client, the LLM itself does not keep track of your conversation. So we're used to maybe with ChatGPT or Gemini or whatever that we're using, we ask a question and then a follow-up question, and it remembers kind of what we asked before and the whole context. But this is not part of the LLM itself, right? This is part of the client. And since in this case, when we integrate LLMs into our Java code, we're the client, so it's up to us to keep track of that memory. Now, the good thing is that with Quarkus LangChain4j, it's built in, so you don't need to necessarily worry about keeping track of memory. It's built in, but you probably want to be aware of that because maybe you want to persist it in some way, so you can do that as well if you want to store it in some sort of caching database or something. Or maybe you don't want to keep track of memory, you can all configure that as well. So by default, it is already kind of batteries included in Quarkus LangChain4j to get you up and running. But it is something to keep in mind. Then you might want to add your own data to the picture as well. So you may have heard of RAG. And this is basically a way to add your own kind of documents, databases, knowledge to an LLM, because of course LLMs have a lot of knowledge, but they don't necessarily have knowledge about your specific use case, your documents, your rules in your organization. So you want to add them to your application as well. So that's another key piece that is relatively easy to do in Quarkus LangChain4j. So there's kind of two ways to do that. The simplest way is with EasyRag. And basically you add an extension and you just point in your application properties to where your documents are, and it'll kind of ingest those documents. The more robust enterprise way is to actually create an embedding and then kind of ingest the documents into an embedding store, into some sort of vectorized data store, and then retrieve those. So that's something that you can do as well. We have an example in the first part of the workshop, which is part of the first workshop that we ran last year, but it is also available for you to kind of look at in the same kind of workshop, because we just created a second section this year. And then another thing that's really key when you want to integrate LLMs into your application is to be able to actually take some sort of action by using tools or function calling. You may have heard of MCP, which is kind of a variation of these tools. But it basically allows you to prompt an LLM, tell it like, here is a set of deterministic functions, tools, functionality, business logic that you can call as part of your interaction. And so basically by adding tools, you can tell an LLM, hey, send an email or something, which an LLM does not know how to do, but you can give it a tool that actually is able to call, to send emails. And what the LLM will do is it'll respond back to your client saying, hey, in my interaction, I determined that you should send an email. The email will be sent, and then basically then we'll craft a response from the LLM based on all that information. But that's really powerful because now you can actually kind of mix and match the capabilities of an LLM, which is natural language processing and kind of knowledge database and whatever more, and then also have some sort of deterministic functionality. And then finally, especially when you start adding tools, you give it access to potentially some stuff on your system, because maybe you'll give a tool that accesses a database, or maybe you have a tool that is able to retrieve something on your system. Maybe you have an application that actually can, you know, like interact with your system. Maybe something like a variation. You want to create your own version of OpenClaw or something with Quarkus, which is totally possible, of course. But what happens if somebody, the LLM does something that it's not supposed to do? So you want to make sure that you add guardrails to your LLM. That means that inputs can, before they go to an LLM, can be sanitized, because maybe you give access to your system with a chatbot and somebody starts prompting the LLM with something that they shouldn't, like ignore all previous instructions, delete the database or something. So what you can do is you can add input guardrails and prevent that kind of even before it goes to the LLM, and then output guardrails, so what comes back from the LLM before it actually returns back to the user, or before it starts calling tools, that you also catch kind of things that aren't supposed to happen. So you can do that on the level of the LLM itself, so the calls to the LLM, but you can also do that on the level of the tools themselves, to also verify that tools are doing what they're supposed to do. So that's already kind of a lot, right, if you haven't worked with AI in your applications. But this is all possible with one single AI service. But what if you want to have something a little bit more advanced? Because really, when you use one AI service, it means that you use one model that you expect to know everything about everything, and you throw a whole bunch of tools at it to do a lot of things. And the LLM is going to get confused pretty quickly if you go into more advanced use cases. So that's where agentic systems make a lot more sense. And instead of using just one AI service, you're actually going to create multiple of these AI services that have a little bit more of a defined domain that they're good at. So they're specialized kind of AI services that we can then make them interact with each other. And that's kind of what the purpose is of today's workshop. So if you're already overwhelmed with the first part, we're here to help as well, and you can go quickly through the first part. But I mean, since the topic of today is agentic, we would like you to focus on the second part, but if you really don't want to, you can do the first part. So if you want to do this hands-on, you want to try it yourself, you're welcome to go to Quarkus.io, Quarkus-workshop-LangChain4J, and then you can do this self-paced, and then you can use the OpenAI key to quickly get started. Like Mario said at the start, if you don't want to use OpenAI and you have your own model, you can perfectly use that as well, and we're happy to help you configure that. If it's some sort of model service that exposes an OpenAI specification API, then it's really easy. You just basically change the base URL. If you want to use something like Ollama or Anthropic's API or whatever, You can do that as well. We'll tell you it's just basically swapping out the extension in your application, and it's pretty simple as well. So for the lab today, you can use just this API key. Again, please don't abuse it. I will go through the entire workshop kind of demo, so if you didn't bring your laptop, no worries. I'm going to show you everything kind of hands-on as well. If you want to do it yourself, just plug your ears or put your headphones on or just ignore me, and you can also do it yourself, and then these people are here to help you as well. Okay, so quickly kind of what we're going to build is in the first step, we're going to implement a first AI agent. It's just basically the same as an AI service, right? So it's just one interaction with an LLM. And so what we're going to build is this car rental service. So basically, you know how it works, right? When you rent a car, you bring it back, and then they have to inspect the car and make sure that, you know, like, oh, there's a little scratch there, or there's something there, and then they try to make you pay more. And but basically, we're pretending we're this rental car system, and we're going to analyze the what the agent who receives, and this is a person, not an agentic agentic system. I should maybe call it a customer service person, not to confuse everybody. But so we have this customer service person that is going to receive the car and then put something into the application that says basically a description of what may or may not be wrong with the car. Maybe they'll say it's just a little bit dirty. Please have it cleaned, or maybe they'll just say it's perfectly clean, ready to go, and then it'll go back to being available for rental. So I'll show you real quick how this what this application in the first version looks like. So should I use IntelliJ or IBM Bob? I'm going to switch between them. All right, so this is IntelliJ. So if you check out the repository, did everybody get the URL that wanted to get the URL? Was I too quick with, okay, we're good. All right, so I'm going to make this a little bit bigger because this is even small on my laptop. Oh, it's IntelliJ, so then it's different. Zoom. I can never, okay. Is this big enough in the back? No, okay, bigger. Fully 200%. All right, so in the source code, you'll see that in addition to the documentation, which you don't need to worry about, that's what we wrote. So you have section 1, which is basically creating that one AI service, and then building on top of that, so you add tools to it, guardrails, RAG, all that good stuff. If you want to go through that, I would suggest, you know, kind of do that whenever you have some time. You have the URL available, so you can go through all this stuff by yourself anytime. But so in this agentic section, we have our first kind of agentic application, and you can see here that we have, under the agents folder, we have this cleaning agent. And the cleaning agent is basically an interface with a system message that just says, hey, you handle intake for the cleaning department of a car rental company. It is your job to submit a request to the provider, request cleaning, blah, blah, blah. And then we also have a user message where we actually plug in the information about the car that was returned. So, you know, like the brand and the model, year, and whatever more. And then we annotate this method with an agent annotation. And we say just a description of the agent. And this description of the agent in this case is not going to be like super important yet, but it's going to be really important later, because the description of the agent is what's going to determine our agentic system to know what each agent is capable of and what it's supposed to do, right? And then we have this toolbox annotation to add deterministic tools to the agent as well. So you can see here that we have a cleaning tool, which is just a fictional kind of deterministic thing, but in a real implementation, this would make some sort of API call or something. In this case, it just doesn't do much. It just kind of does a little data base interaction. And then, yeah, for the rest, we just have kind of a model with the car info and entities and a little bit of database stuff. And then, so basically, we have just this one cleaning agent. So let's start this up. So I'm going to go to section 2, step 1. And start this up. So if you've never worked with Quarkus, so Quarkus has this dev mode, so you can start up your application running on your local machine, and it gives you some nice background information as a dev UI. There's some really cool stuff. If you're interested in that, again, we're happy to show that more, but for the purpose of this lab, I'm just going to start this up. So there's many ways that you can do that. I like to use the Quarkus CLI, and then you can just type Quarkus dev. And then once we start that up, gotta always pose for the picture, right? So this is also starting up a database in test containers, which is also a cool feature in Quarkus. So because I added a dependency for Postgres, it knows that since I don't have a database running on my local machine that's configured into the application, it just starts up a dev service using test containers for the database. So in the meantime, the application is up and running at localhost 8080. We can go look at it. And this is our really fantastic UI. Of course, it's vibe coded. And this was, yeah, like a year and a half ago or something. So we probably could vibe code it like looking a little bit better. But hey, it does what it needs to do. So we have some cars here, right? So we have a Mercedes, we have a BMW, and so on and so forth. So some of them are in rented status. Some of them are in the cleaning status. So basically, the rented status means that this car is rented out and now it's being returned. So I'm the customer service agent that returns, that receives the car. And I'm going to put in a message saying it's full of olive oil. What the heck? You're I feel like this is a trap. Okay, and so when I hit return, what's actually going to happen is that our little agentic system is going to start working. So again, we just have one agent, so it's not super complicated yet. But again, we told it, you handle the intake, and then this is being sent to the LLM. And the LLM is then going to determine whether the car is clean or if it needs to be sent to the cleaning service. So we can see here, we turned on the logs in this case, and we can see in the logs that the LLM said the interior is full of olive oil and requires thorough cleaning and detailing. And then basically it's going to send to the cleaning tool that there's a cleaning requested for this car. So automatically determined it needs to be cleaned. We're going to call the tool to set it in the database to set the cleaning status to true. And so basically, if we now go back to the UI here, we can see that the status has been changed to at cleaning from rented. Now, if we do this for the Audi here, and we can say the car is spotless, then presumably the LLM will determine that it's available to rent, so it's good to go. It doesn't need to go to the cleaning. So it's able to determine, based on just natural language, a path to where it needs to go, right? So this is kind of a basic start of our agentic application. Oh, share is not the right button. Slideshow is. So now we want to create something a little bit more advanced, right? We want to create something that has multiple agents, because what if we also have a maintenance service for doing something with the car, and we want a specialized agent that determines from the natural language that was inserted whether it's something that is closer to cleaning or something closer to maintenance, and then if both are true, which one should take precedence, right? So you can orchestrate these agents in that way. So the foundation that we talked about earlier is, yes, we also still need to keep track of memory. We also need probably guardrailing tools, all that stuff that we created for a single AI service, and we can use that for each of the agents as well. But now we can create some sort of workflow to say, okay, we want to call agents in specific patterns to handle the flow of our agentic system. Then we can also go further into goal-based autonomy, where we give more control to the agentic system, to a supervisor that's also an LLM that decides which agents should be called. And then we can also kind of create our own patterns. But that's a little bit more advanced, and so we'll focus on those first two things. So what you can do is you can orchestrate agents in a couple of ways. So there's programmatic ways to orchestrate agents by using kind of the same patterns that you're most likely used to as a developer, like, well, sequential calls, which is basically just like, I'm going to call one agent, then based on the result of the first agent, I'm going to use that for my second agent, and I'm just going to call them one after the other, and that's kind of the sequence pattern. Oops. And then you can also do parallelization, where you call multiple agents at the same time, and then maybe aggregate the results, and you can save some time by not waiting for each result. You can do conditional routing, basically. If the result of this first agent is this type of result, then call this agent. If not, call another agent. So you can also orchestrate it like that. Or you can also loop and then, you know, maybe give a scoring based on the result of the first agent. Is it good enough? Then we break out of the loop. But if maybe the result isn't exactly what we wanted, we can also keep looping over the agent to refine the results of the agent. So those are the four basic patterns that we're going to look at in the first few chapters of the workshop. So in this step 2 of the workshop, we're actually going to create just a simple agentic workflow where we're going to use the sequence agents. And so by calling the two agents in sequence, we can call one and then the next one. So in this case, we just simply have a cleaning agent. And then based on the result of the cleaning agent, we then have a car condition feedback agent, which is quite a mouthful. But basically, it's going to use the result of the analysis to then determine what kind of action needs to happen. I would say, let's see, yeah, maybe we'll, yeah, okay. So I can show this example as well. So I'm going to stop it. And we're going to go to step 2. And so here in step 2, I'm going to show it in the IDE first, which is really big and it's hard to navigate. All right, so step 2, I'm going to close this. And then here too, we have the same kind of structure, so we just added a few components to our application, right? So in this case, remember how in the first example, we just had one agent. In this case, we have 2 agents. So we still have the cleaning agent, right, that we had for the analysis, and now we add a car condition feedback agent. And so this one has its own system message. It's still an interface, so the exact same structure. It has a user message with the car, make, model, and whatever more that is being passed in. But we also have this feedback. And the feedback is coming from the first agent. So the first agent had the result. And then it had also this output key cleaning agent result. And then in our second part here, we have an agent which has an output key of car condition. So these output keys are really important because they are what's going to be passed to the agentic system into this agentic scope. And the agentic scope is basically kind of what you would...
Yeah, a shared area among agents. I mean, the purpose of the agentic system is making the agent to collaborate, to cooperate. So you really need a shared area where the agent can exchange their input and output. This is a very simple example. It's a sequence of 2 agents. It's called also prompt chaining in this case, because what happens really is that the output of the first agent becomes one of the input of the second one. So this is why it's called prompt chaining. But what happens in reality is that the output of the first agent is written in this shared memory area with this key, the name of the output key, and then the second agent go and take that value from this shared area that we call the agentic scope and do its work.
Yeah. So we now have two agents, right? But how do you orchestrate those? Because right now we just have two single agents. But how can you actually tell them to call one after the other? So that's where you create an agentic workflow. So remember how we talked about sequence and conditionals and loop agents and whatever more. So in this case, we create a sequence. We create one. We want to call one agent and then the next one. So here you can see that you annotate in the declarative way your method with sequence agent, and then you have these sub-agents that you define. And the sub-agents are basically in the order that you want them to be called, right? So we want to first call the cleaning agent, and then the car condition feedback agent. And then we also have the output here, which is also right in this method, where we use the results to then create basically a final determination of whether a cleaning is required or not, and then update the database accordingly. So anything else in this part that we need to show? I don't think so. Just something that we created already in the first part is just a REST endpoint for our front end to call, right? So this is what calls from the front end to process car return, and this is then going to call the car processing workflow, which is the agentic system. So in terms of the demo, it's not much different from the first one, so I think we can skip that and then go to the step 3, which is where things become more interesting, because now we're going to compose multiple agentic workflows together. So in our first case, we just had one agent. Then we created two agents, and we created a workflow with a sequence agent to call one agent and then the next one, right? So what if we want to have multiple of these patterns and use them together? So that's what we are doing here. So we still have our cleaning agent, but in this case, we add a maintenance agent to determine whether it should be more than just cleaning. Something is actually broken and needs to be repaired. So we add a maintenance agent, maintenance analysis agent to the flow as well. And what we want to do is we want to save some time. We want to run those two agents in parallel. So you can see that here on the left side that we have this parallel agent. And so we still have the sequence agent that is first going to call these two at the same time. So the sequence agent is going to call the parallel agent as the first part of its sequence, and then is also then going to call a conditional agent, which based on the result of the analysis is going to determine which agent should be called. Should it be maintenance or should it be cleaning? And it's also going to determine the priority of which one is more important, which, I mean, presumably it is first to repair any kind of mechanical issues before we start cleaning the car, because maybe the mechanics will also make the car dirty and then we'd have to do it twice, right? So we want to do that in the right order as well. And then we can send it first to the maintenance agent and then put it back into the system, and then afterwards the maintenance agent can go into the system as well, say the car has been repaired, but it also needs to be cleaned. So we can look at the source code first for this step, and then I'll show the demo, or we can do it the other way around. George, what do you think we should do? Demo first or source code? Demo, okay.
So you can understand what's going on. Yeah.
All right, sounds good. So I need to start it first. Where did my terminal go? It's like way hidden. All right. Step 3. So again, I'm going to start my application just with the Quarkus dev mode. And it's going to start up the database and a test container again, and then it's up and running. So let's go look at it. So looks very similar, and it's going to look very similar. It's just the back end is going to be a little bit more capable of determining things. So you can see here that now there's a status in maintenance as well. So we have rented, at cleaning, and in maintenance. So let's say that our Mercedes-Benz again is going to be returned, and let's say that the car hit Mount Olympus. And we'll see what happens. So now it's processing, and again, it's going to through the agentic system, right? So it's going to send some stuff, and in this case, we have a little bit less logging turned on, but you can see here that the feedback workflow is going through the different components. So there's the cleaning feedback agent and the maintenance feedback agent that are running at the same time to analyze what happened to the car. And so the cleaning agent is going to determine whether there's something is going on in terms of cleanliness, the other one maintenance, and then an evaluation is going to be made. So let's see what happened here is that it's sent to maintenance, right? Because we actually got some issues, and the LLM, with a little bit of creativity, said that potential body damage and mechanical issues from impact needs bodywork and comprehensive mechanical inspection. So it's very kind of kind of to the point. It's not like, what the heck, like, what do you mean by hit Mount Olympus? So it's just going to kind of make its mind up. But you can also see clean conditions. So the cleaning agent also made a determination and said, yeah, for me, everything is good. And so what happened is in the conditional agent, it determined that instead of going back to being available for rent or being able to go into the cleaning status, it actually needs to go into the maintenance, which out of the three scenarios seems the most likely for this scenario, right? So what happens in the source code, if we go look at it, is that we can go back and look at our agents. And then you can see that now we have more agents, right? So we have the same cleaning agent from before. We have the cleaning feedback agent. We have the car condition feedback agent that we had before. But now we also have a maintenance agent, which very similar, right? So again, the interface with the system message, the user message, and then with some information about the system. And then you can see here the maintenance agent takes the maintenance request as an input, and then as an output key, the analysis result. And then there's the maintenance feedback agent, which again is very similar. It has also a maintenance request as the output. And then basically we tie it all together in the workflows here. So we have a car assignment workflow, a car processing workflow, and a feedback workflow. So the car processing workflow is that main workflow that we saw before. So we have the sequence agent, and now the sub-agents are a little bit different from before, because instead of calling the cleaning agent directly, now we call a feedback workflow, so which is over here, and then a car assignment workflow, and then a car condition feedback agent. So you can mix and match, right? So you can call workflows from the sub-agents, another workflow, and then also directly an agent. And so these agents are going to run one, then the next one, then the next one. But inside is for example, the feedback workflow, which is also a parallel agent that has its own sub-agents, which are cleaning feedback and maintenance feedback. So it's going to call those two agents in parallel, then get the result back, and then delegate that to the next one, which in our car processing workflow is the car assignment workflow. And the car assignment workflow is a conditional agent, which is then going to determine, based on our condition, whether a maintenance agent or a cleaning agent needs to be called. And it does that based on this activation condition. So you can see here that we have the maintenance request, and then we have basically functionality that determines if maintenance request is required. And if so, then this maintenance agent gets activated. And if not, then we're going to determine if the cleaning agent needs to be activated. And if neither needs to be activated, then that's fine too. Then it's just going to be available for rental. Then none of the agents are going to be called. And basically it does this looking at the results from the previous analysis agents that we have instructed to put in their response either what needs to happen in terms of cleaning or respond with a message saying not required. This is where you need to be a little bit careful with your prompting, because in this agentic system, we're looking at the response from a non-deterministic system, right? So we want to make sure that we tell it kind of very specifically what it needs to do and what it needs to respond, and then we need to look at kind of specific things. So we were very specific in the prompts of the analysis agents to say, you know, put this specific string in the response, and then you have a pretty good chance that it'll work. A pretty good chance. Because again, it's non-deterministic, right? So that's always something to keep in mind, or probabilistic, I should say. Anything else that we should show in this step? I think that's the key parts.
Yeah.
Yep.
Say also that everything is type safe.
Yep.
So everything is object. I know the mapping is handled internally by Quarkus. Quarkus will prompt the LLM with the right methods in order to produce, you know, extract your output and take this output, map it to object. So we don't really deal with strings. We deal with normal Java objects. So everything is type safe. And you know, if something goes wrong, an exception will be thrown. So it's a little more safer than, you know, passing strings around. And I think the basic idea is that you break the bigger problem into smaller tasks, and you have all those different ways to, you know, parallelize, execute sequence, pass messages around. Kind of straightforward.
And yeah, I also wanted to make sure that it's clear the way how we are composing agent and the different patterns. So in this example, we have a sequence which is made of 3 agents. The first agent is not a single agent itself, but are 2 agents that run in parallel. The second agent is this conditional thing, so we have 2 agents that can be conditional invoked. And the third agent is a pure agent, so you can mix the 2 things and you can build your own agentic system in this hierarchical way. So basically you have this predefined building block, which are the sequence, the parallel, and the conditional in this case. So there are more you will see, and you can create your own pattern and plug your own pattern in this stuff and combine with the existing ones. And so the idea here is that we gives you, again, the building block to create your own agentic system. Yes, there's a question there. Okay. Yeah. Well, you can break it in microservices, meaning that you probably want an agent to run on each distributed service and then put them together. Typically, you do this via A2A. So there is this protocol that allows you to have an agent running remotely on a different machine, and then you can connect this remote agent with the rest of your local agent, and of course mix the 2 things. There is an example of this in the very last step of this workshop.
Thank you. I think the question was whether like these agents could magically be distributed like on Kubernetes and different microservices, right? Currently, that is not like part of the focus, right?
you can do it, but there is no magic.
Yeah, there's no magic at this point. Like maybe if like A2A gets more advanced and we integrate better with it, maybe at some point that will be possible. But it's not now, and I doubt it will be in the next few months.
On the other hand, you have to imagine that this is Quarkus. It offers 800 different extensions. It lets you implement microservices, serverless. So all those capabilities are there. So you can just, make my agent and I deployed it as as a serverless app, and I have many of those, and they can produce messages and invoke each other. So you can implement pretty much every pattern you want, but not in an automatic way like Quarkus spinning up things on Kubernetes for you, but it gives you the tools to do yourself if you want. Yeah.
Yeah, so I get it. So the point is like you guys mentioned earlier that like you have the agentic scope where everything like contributed. So what the question is basically whether like these different distributed agents could contribute to some shared area and like have the developer not have to care about like how all that is done, right? That is like I would say that's like an ideal state that like enterprise grade microservice agents would get to, but that I would say that's like a mid to far term goal at this point, right?
Actually, well, not too far because we're working on other components. When one of them is like a shared agentic memory, which is external and can persist to some other.
Let's say midterm, right?
Yes. So there are other things in the works. So it's coming.
Another question?
Yeah.
Oh,
Go.
sorry. Yes.
Go ahead. Yeah.
Go ahead.
So in this particular example, the agents were exchanging these output keys, right? But what if there was a requirement for having a session, like an individual session, which kind of forms like a distributed session between these agents? So, like, is it possible to reference a specific session, like pass in a session ID or some sort of a shared persisted state in the exchange between these agents?
So
Mario, go ahead. Yeah.
yeah. So what you do is normally you have one request that goes to the top level agent, and then all the agents are wired in this single agentic system, and there is an implicit session with a key, but you can give your own key through the memory ID mechanism that is also present natively in LangChain4j, also for AI services. So this runs ideally everything inside the same session. I'm not sure what you mean about having different sessions coordinating to each other, but through the memory ID mechanism, you can have different session and reference them through the memory ID if you know the LangChain4j API. So this is implicit at the moment. We don't have this in the example, but you can reference a different session, as you said, or agentic scope through an explicit memory ID.
Well, go ahead, because I don't know exactly.
I mean, the underlying memory mechanism allows you to plug in something else. So now it's in VM, the memory, but you could plug in another implementation that persists to like a database or post messages to, I don't know, Kafka, and someone else could pick it up. So it's all pluggable if you want to do something different.
Yeah, yeah, and again, as Dimitri said, it is a project that we're working on as well, right? It's some sort of shared memory that you can even share with external agents that may not even be written by you, right? So you can have some sort of even external services and share all that memory.
Yeah, we have another question.
Oh,
Hello.
okay.
Okay, minimal experience, hands-on experience with all of this, but intuitively, as a user, I would like a couple of things. I would like to be able to target different LLMs for different substacks or different parts.
Yep.
Great. And second, I would like to treat them as stateless machines and have the whatever context scopes or shared memory or whatnot handled on the Java layer, presumably by Quarkus or the application logic itself. Is that the case? Is that a common use case of this kind of thing in reality?
Yeah, behind the scenes, that's exactly what the agentic stuff that Mario developed does, right? There's a lot of stuff going on, but you don't have to care about it.
Yeah. So yes, this is exactly how it works internally. And about your first question, you can configure the agent with multiple annotation. One of these annotations allow you to say, okay, I want this specific agent to run with a different LLM. So each and every agent can be configured with a different LLM if you want.
Yeah, because like not every agent here needs to have like the same capabilities, right? Like some agents might need like the best model to determine what they need.
Yeah,
Some
exactly.
just like need a very simple model, right? So yeah, you absolutely can. Like the documentation has all the ways you can configure stuff.
Yeah, I just wanted to maybe show, I have this, this is not part of the workshop, but another system that I created, which is this Kubernetes AI ops agent, which is also an agentic system, but that's one of the things here is that some of the agents do actually use a different LLM because some agents, this is basically to analyze logs and metrics to determine whether something should continue rolling out or not. And then I also have another part, which is agents that need to try to come up with a solution if something doesn't go right in your rollout, to kind of analyze the code and then describe the issue and then create maybe a PR if it's possible. But those agents need a more advanced LLM to do that kind of work. So I call actually a different, more expensive model in that case for that kind of work. So you can find that in
Yeah, maybe you want to like share the link to this because this is like a really cool real
Yeah.
world example.
I'll put it in the slide deck and then we can,
Okay, cool.
yeah. I don't know where, somewhere at the back. Yeah, so basically it's just in my GitHub, so github.com/kdubois, and then you'll find the Kubernetes AI ops agent.
We have another question.
Okay, perfect.
For various specific.
We keep coming up with more microphones. I like it.
Thanks.
Hi. So my question is there a possibility to have like permissions in model in these workflows saying that, hey, this kind of a request is allowed to do these kind of certain tasks, but not like some, like for example, I have a workflow which is only available for admins, but not for the general clients.
Yeah, so like Dimitri said, he alluded to this, but let's make it more explicit. Everything that you already have in a Quarkus application, including all the different security mechanisms, you can use in this type of workflow, right? That's the magic of Quarkus. Like all pieces work together, and if they don't, it's a bug, right? So the standard like security annotations like roles allowed or secured or denial or whatever, all that stuff like just works here, right? As a result of how all this stuff is built. So you could place those annotations either on like the REST API that Kevin showed earlier, or you could even put them on the agents themselves, but I'm not sure like how much that would make sense. Anyway, the point is that you can use all the stuff you're used to in Quarkus in this type of workflow as well.
All right.
Thank you.
I believe in this case, as George just says, probably doesn't make sense to annotate in this way a single agent. Probably you may want to annotate the access point, which is the rest endpoint. But yes.
Yeah. Or you can even like add it to the conditional agent, some sort of
Oh, yeah.
logic or something. But yeah. All right. Let's maybe move on and.
I think we had one more.
Okay. Let's do one more question and then we're gonna move on. Yes.
Are you available to switch dynamically between LLMs for an agent while operating,
Okay.
based on conditions and criteria?
This is something we are experimenting with, but in general we found that it's not a good idea. This is because of the chat memory. I mean, what happens is that you have a conversation with a specific agent, and then at some point you switch the LLM, use a different LLM, and then what you do, you have two choices. Either you throw away all the history, all the chat memory, and restart from scratch, which is a little bit defeat the point of having this switch. And the alternative is that you use the old chat memory of the old conversation that you had with the first LLM with the second LLM, which may not work at all. So typically these things are not really compatible. So again, we are experimenting with this, but probably it's not a good idea.
Yeah, but I think what you could do is you can use just multiple agents, right? Because if you're using a different LLM for an agent, then it makes more sense because that's the point of having each agent being specialized, which they can be tied to a specific LLM. And then you can use a conditional agent, for example, to determine which one in that flow you want to call at runtime in that moment, right? So I think that's probably going to be more robust anyway. Because the problem also is that when you start switching LLMs, you probably need to change your prompt as well because LLMs all react differently to the exact same prompt. And that can mess up your agentic system quite a bit too. So oftentimes, just by changing your LLM, it could break your entire system, which is also fun. Yeah. All right, so let's move on to the next pattern. So for now, we've seen like very kind of deterministic workflows inside this probabilistic system, right? But we were very specific in saying, okay, I want to call this agent and then the next agent, or I want to call these agents in parallel, or I want to do kind of this. But that means that you know kind of the flow that is going to happen in your system. It's the best way to use agents because you have more control over the system. But sometimes you actually don't know exactly the different scenarios. And that's where, for example, the supervisor pattern is really interesting. So you can create a supervisor agent, which is backed by an LLM, that you give the LLM the different agents that it has available. And then the supervisor is actually going to determine which agent should be called and in which order. So here you can see that we just have one supervisor agent. We give it 3 different agents, and we tell the supervisor agent, based on whatever the input is, you pick which agent or agents should be called. So that's part of our next step here. So I don't know if we want to go into the details of the planner. Just we'll maybe address that later if we have time, but we'll show how this new system works here. So in this case, in step 4, we actually add 2 different components. So we add a supervisor that is going to determine what needs to happen based on the feedback. So you can see here that we still have the cleaning feedback agent, we have the maintenance feedback agent, and then we're also going to add a disposition agent that is going to basically analyze if the car is just beyond repair and just needs to be dispositioned, sold, or whatever. And then based on those analysis, then we throw it at a supervisor agent that is going to determine what needs to happen based on the determination of those first analysis. And it could be that if the car needs to be dispositioned, what it's going to do is it's going to try to figure out what the value of the car is and then make a decision on whether it really makes sense that it should be dispositioned, or if it's an expensive car, that it should actually still kind of be, try to be repaired instead. And so there's a pricing agent, there's a disposition agent, a maintenance agent, and a cleaning agent. And so the supervisor is going to determine, based on the input, which agents should be called. And so that's kind of the additional components that we're adding to the system. And then also here, because you see now we have these 3 agents running in parallel, and they all have a very similar task to do, right? They all need to do an analysis, just with a different kind of angle to it, with a different system message. But at the end of the day, they're very similar. So what we're going to do is, instead of creating a specific agent for all 3 of them, we're going to create a parallel mapper agent, which is basically going to do the same task but use different kinds of dynamic inputs and outputs for doing this. So we can actually not have all these scattering of agents, but consolidate them. So let's close everything here, close all tabs, and then go to step 4.
So just to reinforce this, what the additional building blocks that we are adding here is that with the supervisor, with the sequence agent, you say invoke agent A, B, and C exactly in this sequence. Or with the parallel agent, you say invoke these 2 agents in parallel deterministically. Or with the condition, you have a deterministic condition to say invoke this agent or this other. Okay. With the supervisor, we are also ceding the control to another LLM. It's no longer that we are saying do A, B, and C. We are saying you are in control of the agent that has to be called. Your available sub-agent are these 3. And this is why the description of the agent is important now, because that string that you saw in the agent annotation is now used by the supervisor to understand what are the purpose and the goal of a specific case, and decide which has to be called and with which arguments. Okay, so now it's the supervisor in charge. In that section of the workflow, is the supervisor in charge. It's another LLM that decides, okay, I need to call this agent and after this other agent. Okay.
Yeah, okay. All right, so the car fell off the isthmus. I didn't type that right, but that's the nice thing about LLMs. They're able to figure out your typos, which is beautiful. All right, so the car fell off the isthmus of Corinth, and we'll see what happens. So in this case, this is a Mercedes-Benz from 2024, C-Class. So, you know, it's a pretty expensive car still, probably. And let's see what happens, right? So it's going to do the processing and then determine whether it should go into maintenance, dispositioned, or into cleaning. Oh, wow, to cleaning, that's interesting. The car requires a full detailing due to exposure to dirt and environmental elements, which, okay, that's interesting. So let's try the BMW X5, which is already in maintenance, but maybe in the maintenance, somebody did something that, or maybe they determined that the car has some bigger issues. So car has some severe mechanical issues, not sure if it's worth repairing. And let's see what happens this time. So again, we're processing. It's going to go through the agentic flow. And then first to do the analysis of the message, and then determining what kind of action needs to be taken. And then the status will change in just a moment. As you can see here, as we're adding more complexity, of course, it goes a little bit, it takes a little bit longer. So the BMW requires a comprehensive maintenance plan, but it determined that it should stay in maintenance, right? It didn't say to dispose of the car. Now, what if this older Ford Focus, and we add the same message saying that, thanks, car has some severe mechanical issues, not sure if it is worth repairing. Right, so basically same semantic meaning. I don't know if I wrote exactly the same sentence, but that doesn't matter. But in this case, we have a car that is much older. So it's, again, it's going through the analysis, then determining based on this message whether it's going to go to the pricing agent, determine more or less the price of this car. And then, in this case, it determined that because the car is 9 years old, it needs to go and be dispositioned. So different outcome based on the scenarios, right? So it's dynamically trying to figure out what's happening.
How come the car is 9 years old?
Yeah, well, good question. So, pro tip, add the current year to your prompt, to your system message. Okay, so let's see what actually happened in the code now, right? So you can see here that we have kind of some logging here. So you can always see, if you turn on the input and output logging, you can see what's going to the LLM and what's coming back from the LLM. But let's see what happened in the code. So we can see here that we have source, and then again our agentic folder, and then the agents, and we have a few different agents this time, right? And so we have the fleet supervisor agent, which is going to determine what needs to happen. And it has different sub-agents. So it has the pricing agent, the disposition agent, the maintenance agent, and the cleaning agent. And then we have this supervisor request, where we're going to build the prompt, the system message for what it needs to do. And with the supervisor pattern, I will make this a little bit bigger, it becomes really important to write a very good kind of system message to tell it what to do, because we're giving basically autonomy to the LLM to determine kind of what agents to call, right? So in this case, we tell it instructions, do not invoke, so this is the scenario if we ask for no disposition. And then also, if disposition was asked, then we add a different component to the system message. So you can also kind of load this dynamically as well. So if no disposition was asked, then or if a disposition was asked rather, then you should do the pricing agent and then the disposition agent, and then if so, then do this and whatever more. So now you might be asking like, okay, but why are we writing all this logic into the system message instead of actually programming it? Well, that's kind of the determination that you need to make, whether you want to use the deterministic workflows or if you want to use kind of more natural language. This is something that you could potentially delegate to somebody less technical to say like, hey, here's kind of the human readable instructions, and they can also kind of try to change it a little bit if they need to. So this is a determination that you need to make. And then finally, you are the fleet supervisor. The feedback has already been analyzed based on these things, and then you should do this. And then we add those different components that we built before. So the system message is quite a bit more advanced here. We had a lot of fun playing around with this to get it right. And using also an LLM to help us along the way to craft this system message. It's interesting, but it is possible, and I think we showed you that finally we did get it working as well.
And, by the way, in the log here, you can see an example of an agent invocation that has been generated by the supervisor. So the supervisor is, at this point, decided that he needs to invoke the agent that does the value estimation, and then and also it generates the argument to be passed to the agent. So this all LLM generated is the LLM that is decided that it needs to invoke the specific agent, in this case to estimate the value of the old Ford and then decided that we want to dispose it.
So here you can see that we have the same card processing workflow that we had earlier, and we change it again, right? So in this case, we have still a sequence of agents that should be called as the kind of the top level, and those sub-agents are now the feedback analysis workflow to do the analysis, then call the fleet supervisor agent, so the supervisor that then also has those different agents and that it can call based on what it determines, and then the car condition feedback agent that we had before. So again, workflow as the first step, then a supervisor as a second step, and then just a plain agent as the third step. So like Mario said before, we can mix and match in this flow what type of agent, sub-agentic system you can call. And then just to quickly show you here as well that we updated the feedback analysis. So instead of calling the three kind of agents in parallel, what we're doing now is we call a parallel mapper agent, which is basically going to call this feedback analysis agent. Instead of the three agents, we just have the one agent now, and then we pass in the in the system message the system instructions based from an object. So in this case, we created a task system instructions, and so we have, I think it's in the model here, we have the feedback task. And so we have different feedback tasks. So we have one with type cleaning, and then a system instruction here, then one for the maintenance with a system instruction. So we just have this, and then we call the agents in parallel with these different system instructions, but that allows you to consolidate a little bit.
Yeah, this is a pattern that I added recently because I found that it's a quite common use case. You want to invoke the same agent but with different argument, and maybe you want to do this in parallel, so and then you collect the result. This is quite typical in many systems. So this is what happening here. In reality, we don't have the different agent. It's the same agent that is invoked 3 times in parallel with 3 different set of arguments. It's like a stream map. It's a map operation of a stream where the mapping function is an agent invocation. So you pass a list with 3 values. The 3 values go through the same LLM 3 times. You are mapping the value with the outcome of the LLM, and then you get the result.
Yeah, and here you can see that with the results, we can also kind of manipulate what happened with the result with this annotation of output. So what happens is that the 3 agents, they all respond with a different result, and they end up in this list, and then we map it basically here to a feedback analysis results for each one of the types of cleaning, maintenance, and disposition as well. So that's our transition from all deterministic workflows to where we mix and match deterministic workflows with a supervisor that also has some autonomy. So what happens if in our car rental agency now, because we gave more autonomy to the system to determine whether a car should be dispositioned, but what if it makes a mistake and it starts dispositioning cars that shouldn't be dispositioned? What we want to do is we want to have kind of a safety mechanism, and we want to actually add a human into the loop. So that's the next kind of pattern that we're visiting here, where we're actually going to, in the middle of the flow, take a break, send back to the human what we have so far, and then let the human decide what kind of action needs to be taken, and then continue the agentic system. So that's the human in the loop pattern. And I think this is really powerful because at some point we can trust LLMs to some extent, but they also sometimes do weird things, and it's good to also have a human in the loop for doing kind of maybe some audit of what's happening and whatever more. So we'll start with the demo, and then we'll show you the code. So I'm going to stop this. And then go to our step 5. And then just like always, start our application. And now we're going to have a human in the loop component to the mix too. So go back to our application, and as you can see, it's pretty similar. We also have generate report, which Mario will talk about in just a minute. But in the meantime, so we have our Mercedes-Benz. So again, presumably a more valuable car, or maybe the Audi Q4, since it's even more recent. And we say, I'm running out of ideas here, but car hits an olive tree, yeah. Is it an Italian olive tree or a Greek olive tree? Okay, and so nothing happened, which is a little bit unfortunate, so we'll need to give a little more dramatic feedback. In this case, it was just like, yeah, you know, you have some damage, and again, the LLM thought it wasn't that bad. So now we can say a car is really wrecked. And let's see what happens now. So the maintenance guy gets the car, is like, seriously? Like this we cannot really repair, but we'll see what happens with the system. Oh, so now we get this approval needed. And here we have some information about the car, right? So it determined that this car is worth $31,000. And condition, the car requires maintenance due to collision damage with an olive tree. And then the AI is also going to give a recommendation. So it says Audi Q4, being a 2025 model, is relatively new. However, the description indicates that the car is really wrecked. And so it's still recommending to scrap it, to disposition it, but it's up to the human to decide what should happen. So we can override that and say, no, this car is really valuable. We really should try to repair it. And we are going to override it. And now you can see that processing, and well, hopefully it's going to stay in maintenance. Yes, here we go. It's in maintenance. And then vice versa, we could have also had, you know, maybe the AI determined that it should be sent to maintenance, but we can override that to disposition it as well. And then we also added to the supervisor, we told it that if it's kind of a low value car, then don't worry about the human in the loop. We gave it some rules that basically said that if it's below a certain value, in this case I think it was 15,000, then disposition it anyway. So we can also say here car is wrecked. And then in this case, it's going to, again, do the analysis, get the pricing, determine that it's a low-value car, and then instead of going through the human-in-the-loop process, it's going to just disposition the car, as you can see here. So no human was required in this case because it wasn't worth it. So we can also kind of make sure that we use humans when they need it, but for menial tasks, for something that's obvious, then skip it. All right, so it's already a pretty nice advanced system now. So let's go look at the code. So let's close all these tabs and then go to our step 4. Step 5, you're right. And then go look at the agents again. And you can see here that we have a human approval agent. And in this case, you can see it's always interface annotated with agent, but we also have this human in the loop annotation in this case. And then with a description of that, what kind of determination it needs to do. And then you can see here that there's an approval service. Mario, do you want to walk through this?
Yeah, so what's happening here is that basically you have an approval services that it's injected through the CDI. What these things return, it's a completable future, so there is a WebSocket that is waiting for the reply for the user, and then when the future is completed, you can move forward and decide what's the output based on the human interaction. So that's how it works. Very, very simple. Yes. It's just a Java code that you can write as you want. So for instance, if you want a timeout, you can set a timeout of the completable future. Then if the timeout expires, you can move forward without waiting for the human. So you really can write what you want here. Yes.
Is that happening in the same transaction with the workflow, or is this like a new status where we wait for the user to approve it?
Well, yes. So far, it's only in the same session, in the same transaction. Yes.
Well, let's just clarify that there's no transaction
Well,
in like the
there's
database sense, right?
Yeah, there's no in a database sense. Yes, true.
So if, let's say, the human don't respond in a lot of time, when we get back which status we set in the UI, with the rollback?
It depends. Still, again, it depends on what you wrote in your code. I mean, the completable future expired, and then you didn't have an answer for the human, and then you write in the code what you want to do in that case.
Yeah, it's right there.
Okay, we have it.
Yeah. So here, you can see if there's a timeout, then basically we do rejected. But of course, that's just what we wrote. It could be anything we want. In the supervisor agent as well, you can see that we added the new human approval agent to the different sub-agents that it can call, right? So we still have our supervisor with the prompt, and in the prompt we also told it that if the value is a certain amount, in this case we just kind of hard-coded it, well, hard-coded in the sense that it's still in a string, but you can see that we have this kind of logic kind of built into the prompt. Yeah.
Okay.
Any other questions so far? Then I think we can.
We have one. Yeah.
Okay.
Approval. What happens? So what happens if there is if we are accepting text from the prompt, and there are some ambiguity in the user message? What would agent decide? Like how it would proceed? And similarly, if there is some kind of a deadlock, I assume there may be kind of looping event into the agents. So how would the supervisor be designed?
So that's really, I mean, yes, you can, instead of having a choice, you can have a text when the user write its decision in a natural language, and then that decision realistically will go through another LLM that will try to interpret it and take a decision. So in this way, you are deterministically say, keep it or dispose it. You can write some text and you are adding one more a level of non-determinism that it's okay, but probably you don't want to do this. So it works. I mean, it really depends how you design it. You have another LLM that will interpret the human response. That's all. Okay.
Did you want to show the report?
Okay. Yes. So. Okay, this is something that we added in this step. Of course, you can put it in all agentic system. What we added is that I tried to create a clear report of what's happening in your agentic system. So this is divided in two parts. First of all, you have the static topology of your agentic system. So here you can see that you have a sequence, and this sequence is made. How can I go? Okay. So yeah, there are lots of agents here, but you have a sequence, then you have the parallel agent there, the supervisor with all these agents, and one agent at the left. So you see the topology, and you also see how the different variables are passed among the different agents. And then here you can see the sequence of invocation. So that's the main invocation that took 58 seconds in total, and it's split by the different agent that has been invoked. So that agent has been invoked 3 times in parallel, as you remember. Then you have the supervisor that it's invoking this different agent. This is the human in the loop bit, and these are the last agents. So for each agent you have the duration, and also eventually the token that you consume.
Yeah, so this, all this information is, you get this user interface by just extending your workflow, right? So it's, in which class is it?
It's in the main one.
Yeah.
So in the work, yes.
Yeah.
So
So you just need to extend this monitored agent, and then you get all this information kind of for free. So this is really helpful, especially when you're doing your development, to kind of see the flow of all the agents. In this case, especially if you use like a supervisor and you want to see which agents were called and what all the context was and everything. Yeah. Yeah, of course. So with Quarkus, if you run in dev mode, you also get this cool little dev UI, which gives you a bunch of information about what's in your application. So all the dependencies that you have, the extensions, they have the option to add a little card to this dev UI as well. So we have, you know, for the database, you can also see like what's in the database, and for our car info and everything, so you can get that. What kind of dependencies. Also, you can even do like a Hibernate QL directly in the dev UI. But what's really cool here is that one of the new features in the Quarkus dev UI in dev mode is that there's also this dev MCP, which basically exposes all the components of your running application, the runtime information, to an MCP server that you can start. So in this case, you can see I've already enabled it. And then you can add this to your code assistant, and your code assistant will actually get all the information about your running application as well. So as you're prompting it with, you know, maybe you run into an issue or something, you can just ask it, hey, what was the latest exception? Can you figure it out? Add a new extension to my application, it'll add a new extension. So this is a really cool feature that we're doing a lot of work in, and which is going to expand quite a bit going forward as well. With also, this one is running as you're running in the dev mode. We're also working on another MCP server that you can start next to your Quarkus application, which you can also prompt for creating applications and creating, you know, hey, create me a link chain for J Quarkus application, and it'll know everything about that application, but also about all the extensions that it may need as well. Do you want to show any? Do you want me to show anything else in the dev UI? Yeah, so in this dev MCP as well, these are all the tools that are available. But then, yeah, so in terms of the LLM itself, so you can see here that in the link chain for J dependency, we can also see all the agents and the AI services that are available. We can see which tools are available. If you ran an MCP server, you can even test it out from this dev UI and call the MCP server and yeah, a bunch of things. Okay, and then finally we have a, yeah, we saw the monitoring. And then in the final step, we're also, well, I guess we have 2 more steps, but we're just going to quickly go through this because we're
two steps in 2 minutes.
Yeah, exactly. We're going to do it. So you can also add multimodal agents. So far you've seen that we always use text to make these determinations. But what if the agent, the customer service person, just wants to take pictures of the car, and then send those in to the LLM. So that's in the next step here, that you actually add an image of a car. It can be like an image of a car that has damage, and then it will analyze the picture as part of its analysis as well. And then the final step is what we talked about earlier, which is the A2A protocol, where we're actually going to externalize one of the agents into its separate Quarkus A2A server. And so you basically can create a sort of microservices architecture where the agents run individually into components that you can deploy individually on your Kubernetes cluster or whatever, but so you can have more of a distributed architecture. So let's go to the final step and start it all up real quick, and then I think we need to wrap up, huh? Mm-hmm. So let's go to step 7, and now I'm going to need 2 terminals, because in this case we have 2 applications. So we have the same agentic system, so the multi-agent system, and then we have one of the agents running remotely in a separate application. So we're going to go to remote, blah, 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 Quarkus dev for the A2A, and then we're going to go to step 7.
That one that Kevin just launched is the remote server, the remote A2A server. So we have an agent that is running remotely on a different service.
Yep.
And this is now the multi-agent system that you have seen so far.
Right. So now you can see that we added a new field here for uploading images. So I think I have somewhere in my downloads, there's the Audi, but I think we had a Mercedes somewhere too. Maybe it's this one. We need a picture of a wrecked car.
There was one in the resources, was the
okay.
Q4.
Yeah. Yeah, but this one's like a clean car.
Yeah,
I want a wrecked car.
I left
Here it
one.
is.
Okay.
We'll use that one. Okay, so this car clearly has damage, so we're going to upload it. And then you can add a message too, and it'll analyze both the message and the image, or just one of them. So let's try it out. Return. And now it's going to actually scan the image, determine what the status is, and then make a decision on what needs to happen with our Mercedes C-Class. So in this case, you can see that it sent it to maintenance. The car requires extensive body work to repair rear end damage. So it saw that it really did analyze the picture. So yeah, that's maybe our last demo because we're now out of time. So I hope that this was at least a good kind of starter for everything. Again, if you want to see another kind of agentic system that's using Argo rollouts in this case, you can check it out here, which is like a kind of a real application of an agentic system. And then I'll give you just a second.
Maybe we should say a few things about, we have a session during lunchtime, second half of lunchtime in MC2 room. We will just be there and hang around if you're going to come and discuss anything about Quarkus AI or whatever, the universe. And tomorrow, Saturday, at the end of the day, we have a session with George to discuss our experience after 7 years building Quarkus, some lessons learned, and it's a big project, more than 1,000 contributors. So, and that's it, basically.
Yeah, and if you like this workshop, you can always add a star to the workshop as well. We always appreciate that. And I was gonna say, so we have a Quarkus logo Lego set, but I have no idea how we can raffle this off. So any ideas of how to do this? I was gonna say add a star to the project, and then we're gonna find out. But I don't know if we can order it.
How about if people come to the what's called the
yeah.
meet the team, then we'll figure it out by then.
Okay, perfect. Yeah, so I'll make the slides available. If you go to LinkedIn, Kevin Dubois maybe, I don't know, and I'll post them there.
Yeah, sure.
So this is me, Kevin Dubois, and if you go to, just find the slides there. I'll post them in the next 20 minutes.
Thank you very much.
Thank you.